Okay, here we are for the next lesson. This lesson is about evaluating generalizations from a sample. And remember, we ended the last lesson having conducted a survey in our class about whether students would prefer to be rich and smart or poor and stupid. No, it was rich and that would skew it if it was rich and smart and poor. It's rich and stupid or poor and smart. That's right. And we came to the that's funny. I because if you had the choice, right, it would be rich and smart, not poor and stupid, clearly. So let here we are then. Is this a good argument? Is this a good inference? That's the question that's in front of us right now. And in this lesson, what we're going to work on is sort of the things to keep an eye on, or the things that we need to know about evaluating or critically thinking about generalizations when we hear them. Again, not every generalization is a good one, and in the last lesson we learned how generalizations should work, what they should look like, and now our question is, then if that's what they should look like, then when they go wrong, what does that look like, or what things are we looking at to know whether they've gone wrong? So is our generalization from the class to the population of the campus a good generalization? Remember, our sample was our class, whichever class I tend to survey, and our target population is, or our population is the entire campus, and the attribute of interest, or what we might call the feature, is percentage preferring to be, I think it was poor and smart, and I think we had 60% generally prefer to be poor and smart. So is that a good generalization? Well, again, now, whether that's a good generalization or not depends. And it depends on whether the class is typical. Now, when I ask whether the class is typical, what I mean is typical is sort of a relative term. And what I mean is not like it doesn't have a definition. I mean that it's always defined in relation. If I say that it's a typical day, then I'm defining today in relation to other days, right? I'm showing that it bears this certain relationship to other days. And that's what makes it typical. To call a sample, to call a generalization, to call the class typical is to say that it is reflective of, or more specifically, that it represents the campus, the thing that we're generalizing about. So the question here is, does our class have the properties the overall student population lacks? Does it have any properties that our overall student population lacks, or vice versa? Because if the two groups, our sample and our population, are different because the sample is atypical and has properties that the population doesn't, then that could affect how people answer the question. That could affect my feature, or my attribute of interest in the survey, right? So, and in fact, that's likely going to be the case. We'll work through that in a bit. But when that happens, we refer to our sample as being atypical. So one of the first things you want to do is you want to focus in on the relationship between the sample and the target population, and ask whether the sample is really representative or typical of the target population. And if it's not, we refer to it as atypical. Now, in the survey that we conducted, the class that I would conduct this survey in for Phil 100 at COTC is atypical. Why? Well, because it's not representative of the campus population, which is what my conclusion is about, which is what our our target population is. Well, how is that so? Well, first, the student population in my class is on average going to be older than the overall student population on the campus. I have older students generally, because generally older students are the ones that apply to COTC and go to school at COTC. At the four-year college, it's typically more the younger students, right? And now here's what makes this atypical, because older students might have a different take on the question. Do you think that age might have a bearing on how we answer that question? See, if age is a difference between my sample and the target population, that is, between my class and the campus, and if age has a bearing on how we might answer that question, then my sample is going to be atypical, or what we might refer to as biased, okay? But we'll refer to it as atypical most often. Your book makes a note of both. It can be atypical or biased, but we're going with atypical, okay? Now, in order for things to run smoothly here in this kind of generalization, you have to have the same related variables in your sample and your target population. That is, any variable that has an impact on the feature. Now, in our case, the feature or the attribute of interest is the answer to this question, right? So now, in our survey, our generalization will be bad if there are variables that we call related variables, or things that impact how we answer that question, that are found in different proportions between my class, or the sample, and the campus, my target population. All right? All right. So a sample that has a related variable not in proportion to that found in the target population is what we will refer to as atypical or biased. Okay, that's the very first thing, by the way, in your book about evaluating an argument. This language. So that's what we mean when we use that phrase. Now, being older is possibly a related variable. It is related to one's views on whether it's best to be poor and smart or rich and stupid, right? And our sample has a disproportionate number of older students, so potentially it's biased. There are a few other potentially biasing factors in the sample relative to the feature we're interested in. There are disproportionately few women in my classes sometimes. The campus on a whole is largely female between OSU and COTC. COTC is much more frequently, statistically, much larger percentage of female students to male students, which is good, I guess, for the male students. Good for you. But the numbers are disproportionately high for women. But in my courses, the areas of study that my courses draw from for enrollment, I get a lot more males. So I don't have nursing students. I don't have medical sonography students. I used to, but I don't, and they're looking for a way to draw them back into these courses. But those programs are almost entirely dominated by the ladies. Whereas the engineering I draw from accounting, which has a little bit better male to female ratio. I draw from Associate of Science degrees and Associate of Arts degrees, just the straight 2-year degrees. There are a number of these programs that my students draw from. And so generally I get more males in my class than are typical for our campus as a whole. All right. Now, that's another potentially biasing factor. What do I mean by that? Well, what I mean by that is that whether you're a male or a female might have an impact on whether you would prefer to be rich and stupid or poor and smart. Could very well have an impact on that. Maybe gender plays a role. I don't know. We don't know. It's a potentially biasing factor. Can you think of any other biasing factors? Here's another one. A higher proportion of returning students than the overall student population, right? COTC has more returning students. Students who went to school or left school for a long period of time who are now coming back to it. So my classes will typically have a higher number of those. My classes also typically have a higher proportion of commuter students than OSU. There is a dorm on campus. There are campus dorms, and COTC gets some rooms in those dorms for our students, but typically our students are commuters. You are not a commuter because you're taking this online, haha. So, but yes, we get a high number of commuter students. And what else? COT students have a full-time work more than average. That was a genius way to put that. Most of my students at COTC and in my courses work full-time and go to school part-time. That's just how it rolls. But I don't think that that's true. That's at least potentially not true of or at least it's found in a different proportion than in the campus as a whole. So that could be another potentially biasing factors. There will be others. Again, my students will be exclusively and only COTC students, but the campus consists of both COTC and OSU students. So there you go. All right, now here's a note. When I use the term biased, be clear that when I use that, I'm not talking about a prejudice or an opinion that something is bad or wrong. That's not. I know that that's typically how we use the word bias, but in generalizations and scientific sampling, a bias just means that there's something that will skew the consistency between our sample and our target population, between our class, what we find in our class, and what we'll find in the campus as a whole. Whatever that thing is that will disrupt the consistency of results between the two, we refer to as a bias. So a sample of an overall target population, as a sample of the overall target population, this class, my classes, are biased simply because there are variables related to the feature or the attribute of interest, that is, whether you prefer to be rich and stupid or poor and smart, that are present in wrong proportions, in a disproportionate amount. Okay? All right. Now, one question that will come up for students is then how can we be sure that our samples are not biased, right? If I want to engage in a generalization, then how do I know that how can I be certain that I am being unbiased? Well, you can't. You can't know ahead of time that your sample will be unbiased because you can't take account of every single feature that could potentially bias a group. There's just almost no way to do that, okay? But what we can do is when we are biased. So I can't create a perfectly unbiased situation, but what I can do is point out biases when I see them. And then we'll know about specific biases and we can look to avoid those. Okay? We know some variables might well be related to whether a student would prefer to being, poor and smart or being rich and stupid. And so we can look for those variables ahead of time to make sure that they're in the same proportion. Things like grade level, economic background, our major, these sorts of things are things that we can look for. Whatever we do, though, we have to be very, very careful about generalizing from a potentially biased sample. And again, remember, biased sample just means that there's some variable that impacts on the feature or the attribute of interest that is found in different proportions between the two. Okay? All right, and we want our sample generally to be large enough so that we can tell if it's biased. This is why a lot of times when we generalize, people know, well, you need a big sample, you need a big sample, you need a big sample. Not always, by the way, but generally, here's why. Because that allows us to see biases more clearly if we have a larger, and to counteract biases more clearly if we have a larger sample. So you have to be cautious about generalizing, and this is the final note of this lesson. We have to be very careful about generalizing from a small sample. Small samples can be inherently biased because in a super small sample, let's say a sample of 1, there are a lot of potential biasing related variables that could impact the feature that we're looking for between that one individual and the entire group. This is why you need a group and a sample, not just one, and why your group needs to be adequately large. Now, there'll be more to say in the scientific sampling lesson about the size of a sample and how good we can know that that generalization is based on the size of the sample, and about how to pick our sample to make sure that the variables, the related variables, are the same between them. But that will be for the next lesson. All right?